Okay, so today we're doing 15.1, understanding geometric sequences. Make sure that you put this in your as a new section in your notebook. Okay. Exploring growth patterns of geometric sequences. The sequence 3, 6, 12, 24, 48 is a geometric sequence. In a geometric sequence, the ratio of consecutive terms is constant. The constant ratio is called the common ratio, often represented by R. I think we should go ahead and put that in your notes after you've written that title. Okay, and also remember, make sure that you take all these titles. Even if I don't highlight it, make sure that you are writing these titles in your book. All right? All right, so it says complete each division. 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. And 48 divided by 24 is 2. Now, really what I want you to pay attention here is that it's the next term, the terms that they're dividing, right? You've got the first term dividing into the second term, okay? And you have the second term dividing into the third term, okay? And so on and so forth. So you got the, if I was trying to figure out this and I had the ninth term and I divided the ninth term by the eighth term, I would still get this R, okay? You'd still get this constant R no matter where you are. As long as you're taking the term that you're at, you're dividing it by the previous term, okay? So the common ratio R for the sequence is, well, 2, as we have figured out. It says use the common ratio found to identify the next term in the geometric sequence. Next term is 48 times 2, which is 96, okay? All right. I try not to, I apologize about that noise. That's me putting the marker back. All right. Again, you want to put this into your thing. I'm not going to highlight it. It says explain extending geometric sequences. All right. The thing I do want you to write, okay, in Explore 1, you saw that each term of geometric sequence is the product of the preceding term and the common ratio. Given terms of a geometric sequence, you can use this relationship to write additional terms of the sequence. Now, what I do want you to do is I do want you to write this, finding a term of the geometric sequence. For n greater than or equal to 2, the nth term, f of n, of a geometric sequence with a common ratio is f of n equals f of n minus 1 times r. Okay, so you need to know the previous term to figure out the next term. Okay? All right. Make sure you write that. All right, here's some examples. I'm going to do you one. All right, find the common ratio R for the geometric sequence and use R to find the next 3 terms. So they give 6 to 12, 12 to 24, 24 to 48. We take the second term, 12, and we divide it by the first term, 6. We come up and we figure out that that's 2, so we take 48. Oh, I put 42. Whoops. That's the answer to everything, right? 48. Oh, man, dude, I don't know what's happening. And all of a sudden, this thing's going weird. I will erase that. All right, so we got 48 times 2. We already figured out that that's 96. We take 96, you multiply that by 2. You get 2 carry the 1, that's 18, so you got to, that's 19, 192. And you take 192, and you multiply that by 2, and that is 4, 8, carry the 1, 384. Gee whiz, I hope that's all right. You know what, I should probably take out my calculator to ensure that. But, you know, I'm not really that concerned with it at this point in time. If I'm wrong, you'll let me know, I'm sure. So I found the next terms of the sequence. Did I write down what R was? Yes, I did, okay? And I should actually put that equivalent to R, by the way. All right. All right. All right, next one is, so you're going to take 50 and divide it by 100. Right? And we can all see that that's 1/2. So that's our R. Okay? So now we got to take 12.5. 12 and 5 tenths, sorry. Multiply that by 1/2. And we get, let me see. You know what? I better get my calculator out because I'm able to do this one. But I just want to make sure that I do the next one. So this is setting it up. Divided by 2, right? So you got 6.25, 6 and 25 hundredths, right? And then you got 6 and 25 hundredths times 1/2. And then we're going to that. And then I got 3 and 125 hundredths. And I take 3 and 1 25 hundredths. And I multiply that by 1/2. And I get 1 and 5,625 10 thousandths. Okay? All right. Very good. Now, on the next page, you're going to do you are writing all the examples, okay? I'm not highlighting the examples because that'd be a lot of highlighting, so make sure that you are writing the examples. Okay. I want you to do this. Go ahead and pause the video. Go ahead and do this. Come up and show it to me once you've done it on a whiteboard so I can give you credit for it. Okay. All right. Next, recognizing growth patterns of geometric sequence in context, okay? So that means we're talking about it in a word problem, all right? So you can find a term of a sequence by repeatedly multiplying the first term by the common ratio. A bungee jumper jumps from a bridge. The table shows the bungee jumper's height above the ground at the top of each bounce. Okay, so what they're talking about is that it's already hit the bottom, okay, and it pulls them back up. The heights form a geometric sequence. What is the bungee jumper's height at the top of the 5th bounce? All right, they've given us the first 3 bounces, so we can go ahead and take 80, divide that by 200, okay, which is really just 8 divided by 20. All right, and a little bit of easy calculation says that ratio is 4/10. Okay, I could have probably just done that. All right, so they're giving us 32, and we need to know what 5 is. I'm going to go ahead and put my R up here. My R is 4/10. All right, so now I'm going to take 32. So this is my 4th one. So I'm going to take 32, and I'm going to multiply it by 4/10, and I'm going to get so the 4th time he only comes up that far, which is 12 and 8/10 of a foot. All right, and then we got the 5th bounce, which is the one that we're really looking for here. So we take 12 8/10 and multiply that by 4/10, and we come up with, luckily all I got to do is, okay, so he comes off the ground 5 and 1/1200 feet, okay? So what they're talking about, again, just so that you can understand this, it's the recoil, right? The bungee cord extends completely, pulls the guy back up. That's the bounce, okay? That's what that first bounce. All right, depending on their height, I guess is probably how that's all working out. All right, so that's problem 1. I'll go ahead and do another one for you. You remember, you want to write this. Now, you don't have to draw the picture, okay? Just write the chart so you can use that. I wanted to give you a picture so you can take a look at it and see what it looks like, okay? So you can see that he comes off, so the next bounce will be 12 and 8/10 of feet, and then 5 and 12/10 of feet, which would be, that's probably the scariest one, believe it or not. That first one's a little scary too. All right, so here's example 2. Remember, you're writing all these examples. All right, a ball is dropped from a height of 144 inches. Its height on the first bounce is 72 inches. On the second bounce and third bounces, height of the ball is 36 and 18 respectively. The heights form a geometric sequence. What is the height of the ball on the 6th bounce to the nearest 1/10 of an inch? So we can round here. So all right, so what I'm going to do is I'm going to go ahead and make a chart. So 1st bounce, 2nd bounce, 3rd bounce, all right, and we're trying to get all the way up to the what bounce? 6th bounce, 3, 4, 5, 6, all right. So our first bounce was it's dropped, but we don't care about the drop height. We care about the bounce. So 72. Or do we? No, because that's first bounce. Second bounce is 36. Third bounce is 18. So we're going to take 72. Take 36. 36. Okay, and it's 72. Oh man, I keep messing that up. We're going to take 36 and divide it by 72. Okay, pull out my handy dandy calculator. I would have this on at all times, so 36 divided by 72, and that looks like half. Okay, so I wasn't sure. All right, I'm going to put it in decimal form because that's where we're going to be answering these. So I'm going to take half of 18, and that's 9. Half of 9 is what? 4 and 5/10, and then half of that is what? 2 and 2500. So 2 and 2500. Okay, excellent. And that's what our answer is, 2 and 2500. Oh, let me label my R. Make sure that you label this, because again, I'm making the video. I'm just trying to hurry along because I don't want these videos to last forever. All right. Go ahead and do this on your own. Bring it up to me so I can check it, and then you could go ahead and start on your homework. Yes. And that is on HRW. Do 1 through 21 odds only. Remember to show all your work. That is to be turned in. Okay. That's all I got, guys. So it's not too painful.